better place. We are smart at what we do to make our world a better place. By the help of God, to make our world a better place. By the help of God, to make our world a better place. Smart do.
How are you, students? Hope you are doing well at home. Today I want to learn physics as a subject, and for that reason I want to go direct to the capacitors. Ask yourself, what is a capacitor? I will answer you for today, but tomorrow you are the one who is going to answer that. Number one, you are supposed to know that a capacitor. What is a capacitor? Maybe you have gotten a chance at your home, a spoiled radio. You can see there are so many cylindrical, look like types of things that are mounted at the lower part. So those are the capacitor and cylinders. They are capacitors and resistors. So today I want to discuss on the capacitor, and I want to know if you know the definition of capacitor. What is a capacitor? Let me answer you today. Capacitor, these are devices used to store electric charges. So, what is a capacitor? Capacitor, these are devices used to store electric. They are used to store electric charge. So when I'm marking for you, I'm going to write the term to store. They are used to store. They are not used to produce. So I give you one mark. They are used to store. So when you're defining the capacitor, I'm supposed to see in your answer, what is that? It is used to store. So I have to see the term store. And that, they are used to store what? They are used to store electric charge. They are not used to store only charge, but they are supposed to store electric charge. So I have to see the term electric. So I mark for you, and then you get 2 marks. So they are used to store electric charge. That's the definition of a capacitor. The next thing I want to go to do you know the symbol that is used to refer to the capacitor? Yes, you know, because their used symbol is this one. It is that symbol. You can ask yourself at home maybe, what's the difference between this symbol and a cell? I'm going to tell you. A cell, the symbol of a cell is the one that we use. The longer, each stick, one is longer, the other one is smaller. You can see this longer, but for the case of a capacitor, they are both of the same height. I hope now you have seen the difference of a cell. It has 2 sticks, but one is smaller. The one that is smaller is the one that is the negative, and this is the positive. So knowing that, I think you are good to go. The next thing, let's go to the arrangement. We have several of arrangements, but in this topic, let's go to the parallel arrangement. Parallel arrangement. Ask yourself, have you ever seen a parallel thing? For example, in mathematics, we say that this line is parallel to this. They will never meet. That's one property of parallel lines. Those are 2 parallel lines. They will never meet at a point. They are like two roads, 2 level lines. They are never going to meet. For example, if 2 vehicles are going opposite direction, they're never going to meet. Leave about what you are thinking. What about accident? No, this time we are not going to focus on that. So let's go direct to the arrangement of the parallel arrangement. Number 1, so you can have these are capacitor. Then you have another capacitor here. This is another capacitor. So For example, this capacitor C1, this capacitor C2. And then you're being told, can you get the total or the effective? So you say the total effective, we say that the total or the effective capacitor, we are going to say that the total capacitor is equals to C1 plus C2 plus, maybe going that way. And then this is a very crucial formula you are supposed to note at your notebook. Can you have it in your notebook? CT, or this C total, is equals to C1 plus C2. And then you can have more capacitor. So for example, you have C1 given as 4 microfarads. 4 microfarads, and then the next one is 5 microfarads. 5 microfarads. And then you're being asked, can you calculate the total of the effective capacitors? So you have been told it was connected to a 12 volts battery, and then can you find the total of the effective capacitors? So what are you going to do? You have the formula with you at your notebook. What are you supposed to do? You students, can you now use the formula to find the total of the effective capacitors? So the question was, find the effective capacitors. What are you going to do? Knowing that you have the formula, knowing that you have the question, what are you supposed to do? 1, can you know how to substitute the formula directly using all the given figures? So we say the total capacitor is equals to C1 plus C2. In our case, we just have 2 capacitors which are in parallel. You can see they are in parallel, they never meet. For example, if you protrude this line to this, they will never meet. So we say the arrangement is in parallel. So we say is equals to what's the value of C1? C1 we had been given as 4. C1 we had been given as 4 microfarads, plus we have the C2. The C2 we have been given as 5. It's given as 5 microfarads. Is equals to what? Is equals to what? When you add 4 plus 5 microfarads, it becomes these microfarads. It's not a new, it is a microfarads. It becomes 9 microfarads. 9 microfarads. Having known that CT is equals to you add the sum of the all capacitors that you have. If you had 3, you add 4 plus this one and plus the other one. So, what I emphasize more, can you note in your notebook this formula? Can you note? Because next time I'm going to bring it in your exam. And then you start doing pity things. So I don't expect the same. So when I'm asking the total of the effective capacitance, just add the way they are. Just add the way they are. I hope you have enjoyed my class. See you next time. Thank you very much.